Okay, ladies and gentlemen, welcome back to this graph. The last video homework was how to make a graph about the relationship between mass and volume. And now we are going to use this graph to answer our question. And now remember the driving question behind this lab. Let's write that at the top here. I'll write at the bottom. The driving question here is, what is the relationship between mass and volume? Relationship between mass and volume. That's our question. That's what our graph is about. And our graph is going to answer that question for us. Well, how does it do that? Well, we have material A and we have material B plotted very neatly on our graph. And we have nice best fit lines. Once you draw the best fit line, we don't care about the dots anymore. I could have an outlier way out here for material B. It doesn't matter. All I'm looking at now is the line itself. And the lines both show a positive relationship. They both increase volume. As they increase volume, the mass increases as well. So there's a positive correlation or a positive relationship. But they have slightly different relationships. Material A has a much steeper line than material B. And that steepness is called slope. And slope is always going to be the answer to our question. So slope equals steepness of the line. And since the two lines have different steepnesses, they have different slope. Math class, you get the formula. By the way, everything I'm writing here, you can write. If you do a little rough draft of the graph, that'd be great. So the formula is slope equals y2 minus y1 over x2 minus x1, not x squared, x2, sorry. That's the formula for the slope. But what does that mean? Well, it means that we need to choose 2 points on our graph. And we need 2 points that we know the exact value of. I could choose this point right here. That's a valid point to choose, but I don't know exactly what the value is because it's between, what is that between? 50 and 45, 50, between 45 and 50. It's between 40 and 44. I don't know exactly what it is. But if I come and find this point right here, I know exactly what that value is. It's 20 and 16. Now my y value, y-axis, is the mass. So this point right here is my first y value. So y1 equals 16 grams. It's also my first x value. So x1 equals 20 centimeters cubed. And you identify and label each point that you're using. I don't need just one, I need more than one, I need another one. So I'm going to look on my line here, and I'm going to look until I see a point where it crosses exactly. And this is a little bit confusing, but that looks like it does too. This is my second point. So this is, now notice I'm not going from the data point, I'm going from where it hits the line. So y2 equals 36 grams. And it's also my x2. So as x2, it equals 40 centimeters cubed, or milliliters, same thing. So now I have 2 points identified on my graph, and I'm ready to go and put it into my formula. So y2 is 36 grams, minus y1 is 16 grams, divided by x2 is 40 centimeters, minus x1, which is 20 centimeters cubed. And I simplify. 36 minus 16 is 20 grams, and 40 minus 20 is 20 grams, 20 centimeters cubed, sorry. But I'm not simplified as much as I could be yet. I need to simplify it all the way down to where I say so many grams over 1 cubic centimeter. 20 divided by 20 is indeed 1 gram. gram per centimeter cubed. Now that's kind of strange. I'm going to go back and double check that. Y2 is 16, 20, so 16 and 20, 36 and 40. Okay, there it is. So we're going to do the same thing there for material B to walk through. First thing I need to do, so this is slope for A equals 1 gram per centimeters cubed. This means that if I had 1 gram of this material, it would fit into 1 centimeter cubed. Or if I had 1 centimeter cubed of this material, it would have a mass of 1 gram. So coming along, there's a good point, and there's a good point. So this is my first one along the line. So this one here, my Y1 is 32 grams. It's also an X, my first X, 60 grams, centimeters cubed. Units are very important even though I'm messing them up. My second point, and you do have to show me all of this work. Everything I'm writing, you have to write every single time. So Y2 is 44 grams. X2, come down, is going to be 80 centimeters cubed. So I'm going to work, let's see, I can work in this space. So slope equals Y2 minus Y1 over X2 minus X1. Y2 is 44 grams minus Y1 is 32 grams. Divided by X2 is 80 centimeters cubed minus 60 centimeters cubed. And I need to simplify this. And this time I'm going over here to grab a calculator because I'm going to cheat. So I have 44 minus 32, which is 12 grams, divided by 80 minus 60 is 20 centimeters cubed. Now this is not simplified all the way down yet, so I need to take 12 divided by 20. And I get 0.6 grams for every centimeter cubed. So this time, if I'm holding a 1 centimeter cubed piece of this material, and I put it on the balance, I'm going to have 0.6 of a gram. And this is the slope for B, material B. When you come to class tomorrow, I want you to have the slope calculated for both of your materials, and that will receive a stamp tomorrow. Have a good day.